All right, hey everyone, we're going to dive right into these notes on translations on a coordinate plane. So translations are a thing that happens to a figure and they move the figure every point the same distance and direction. So distance, there we go, and direction. They can be moved horizontally or vertically. I'm going to write up and down and left and right. Okay, so up, down, okay, or left and right. And they can be thought of as slides. I'm not going to be using the word slides in this video. I'm going to use the word translations because that's what they are, right? So where you use this in real life, think about walking on the floor. You're moving your body from one position to the next. The floor is your coordinate plane, and you are walking, translating your body up, down, left, right on the coordinate plane. Okay, sports or football is another good way to think of this as well. But let's look at this first example, number one, and it wants us to translate this figure or slide it 5 units to the left, okay, and 2 units down. So it's looking like left and then down, right? So we are gonna first write our first point, which is A. A is 2 comma 4. B is 6 comma 7. C is 7 comma 3. Okay, so if I move this point to the left, as it said 5, we're going to go take that point and count 1, 2, 3, 4, 5, and then down, I believe it said 2. Okay, so then 1, 2. So my first point there is A. My next point is B. So we're going to do the same thing 1, 2, 3, 4, 5, and then down 2, 1, 2. That's my B. And my C, same thing. 1, 2, 3, 4, 5, and then down to 1, 2. There's my C. So if I connect the dots, I should see a picture that looks like it shifted a little. And then if I write my new points, my A prime, I have negative 4 comma 2. My B prime is 1 comma 5. And then my C prime, my new C, is 2 comma 1. So then if I look at my ordered pairs, it says look for any patterns and describe what happened to the x and y values in each ordered pair. So the easiest way to look at this, and remember when we're talking translations, every single point moved the same distance and direction. So let's look at C so I can do some easy math. From C to go from 7 to 2, that says x decreased by 5. And y decreased by 2. Okay. So then what would that rule look like? X decreased by 5. Another way to say that is x minus 5. And the other way for the y value is y minus 2. Okay, so this will be my algebraic representation. All values of x were decreased by 5. All values of y were decreased by 2. Okay, all right. The same concept applies for if they wanted us to go to the right and as well as up. So let's look at this example. We are going to go to the right 4 and up 3. So let's look right our coordinates E, D, F. And I know I'm not doing this in order, but I'm going to start with E because I saw it first. E is negative 4, comma 1. D is negative 7, comma negative 4. F is negative 3, negative 5. Okay, so then if I write my new coordinates based on that, well, first let me go ahead and just go to the right 4. So that would be 1, 2, 3, 4. And then up 3. 1, 2, 3. So there's my E. Then I have my D, 1, 2, 3, 4, 1, 2, 3. It's my D. And then F, 1, 2, 3, 4, 1, 2, 3. So if I connect my dots, there we go. Okay. So I should be able to see that it looks like it's slid. It almost makes kind of like a 3D looking shape, but that's neither here nor there. My new coordinates, my E prime, would be 0, 4. My D prime became -3, -1. My F prime became 1, -2. So then I'm supposed to look at my X and Y values and see what happened. So I can say that X increased by 4. And my Y increased by 3. Okay, so algebraically, increased means plus. So for this, we would say X plus 4. Okay, then we would say Y plus 3. All right, so I'm going to give you a little tool here to use to help you out when we're doing translations. I use a number line, and so I would go for up and down. So let's say this is plus, this is up. For minus, this is down. And let's make this a 0. This is for the y-axis, right? So up is positive, down is negative. For your x-axis, you have minus for left, plus for right, okay? This is your 0. This is for the x-axis, okay? So use this if you need it, right? It's an easy way to count too. So I'll show you what that looks like in a second. So number 3 and 4 give you examples where they don't tell you what's happening and we need to be able to figure it out, right? So at first I need to know where my new is and my original. This one's my new, this one's my original because I have the little marks there, the little prime notation, right? So I know that this went up and I know it went to the left, okay? So up is y plus, left is x minus. So now we just need to figure out by how much, right? So we can write all the points, but remember, translations move all the points the same distance and direction. So I'm going to use point I. Now, if you want to write all the points, please do. I'm just going to write point I though. Okay, so I, the point is 5, comma, -1. And my new I is -2, comma, 3. Okay, so what happened for me to go from negative or 5 to -2? Well, that's left 7 because 5, to get from 5 to -2, it would take me 5 points. Let's say if I did a number line, right? If I started at +5 and I'm trying to get to -2, here's 0. To get from 5 to 0 is -5, okay? And then I still have to go to -2. So if -2 is here, I need to subtract 2 more, which would make -7. So that's left 7, okay? Because remember, x is negative and that's left, right? Then we know to go from -1 to 3 is just 4. We're going up 4. It's a +4. So up 4. So my algebraic rule here would be x minus 7, okay, comma, y plus 4. All right, so then the question asks us, do we notice anything about the line segments in the pre-image and image? So the original and then the new. The line segments 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The line segments stayed the same. They are congruent. Okay, they stayed the same. Okay, they stayed the same or they're congruent. That is important to know. Okay, so then if I look at this point here in number 4, well, this time my original is here, right? Because notice no notations. If I look at L and M and N, I can see that there's a little notation right there. So this is going to be my new, okay? So this tells me that I went to the right and I went down to make my shape. So now I just got to figure out how much. A student pointed out to me in class that if I picked a good point, let's say I picked L, L, the original point is -2, comma 2, and my new L is 7, comma -7. Because those numbers are the same, it's really easy to see what happened, right? So how do I go from 7, right? How do I go from 7 to, or from -2 to +7? So if I started at -2, I have to go up to get to 7, right? So we know to get to 0, that's +2. And then to get to 7 would be +7 more, so +7. So 2 plus 7 is 9. So that means that I went to the right 9. Okay, I didn't use the right number line for that. I apologize. This is supposed to be for the x-axis, but the same concept is going to work for my y value as well. So to go from 2 to -7, so let's say I'm at +2 and I need to go down to -7. I need to go to get to 0 would be what, -2, and then to get to -7 would be another -7. So that would be down 9. Okay. So if you're ever struggling with integer operations, a number line is really helpful. So now knowing that it's right 9, like right and down, see, right and down, then I can say my algebraic rule is x plus 9, comma y minus 9. Okay. All right. And then now to look at my angle measures, what do I notice? Did the angles change size? If the side lengths didn't change, when I slide this figure over from here to here, the angles should stay the same as well. So my angles are also congruent. So I write congruent instead of stay the same because congruent is a bigger word, but it's a more important word when we're talking about preserving congruency and orientation. Okay. All right. So we got 2 more or 3 more to do. And as I remind you, remember when we're translating a figure, we don't need to translate every single point to figure out the algebraic rule. And we're going to prove that with these translations here. So with number 5, it says to go from 12 to -1 and from 7 to 14. Okay. So to translate from 12 to -1, that tells me that I went negative, I decreased. So how much did I decrease to go from 12 to -1? Well, I went to the left 13, okay? So that's left. Then I went from 7 to 14. Well, that's an increase from 7 to 14. So then I went up 7, okay? I don't need to rule there because this wanted me just to describe the translation. So then look at number 6. I have from -6 to -5. That's an increase, right? So how much did I increase to go on the x side to go from -6 to 5? That's an increase by 1. So I go to the right 1. Okay. And then I went from -8 to +2. That's an increase as well. So that would be an up 10. Okay. On number 7, and if you don't see that before I go to number 7, to go from -8 to 2, if I'm using a number line, if I started at -8 and I entered +2, to get to 0, I have to add +8 to get to 0, and then I add 2 more to get to 2. 8 plus 2 is 10. Okay? All right, so then on number 7, this translation says we went from -3 to -9. That's a decrease, right? We decreased by 6, so that is a left 6. Okay, and then on the y side, we went from 6 to -1. That is also a decrease, and we decreased by, so 6 to get to 0 and one more, so that's down 7. Okay, so hopefully you were able to use these notes to help you out understand translations. If you have any questions, please see your teacher. Ask for tutorials, pause, rewind if you need to. Other than that, these are the notes. Hopefully that's helpful for you. And until next time, you guys have a good day. Bye-bye.